not completely, but a different topic with this problem. This is about a topic where we say velocity is relative. See, you can only know how fast you're going if you compare yourself to something else. There actually is no spot in the universe with a little sign on it that says, this spot is stationary. I mean, think about it. Right now, wherever you're sitting out there in the world, sit still. All right. You're not moving, are you? And you say, oh, no, I'm not. Yes, you are. You're on a planet that's moving around the sun at thousands of miles an hour, while, by the way, spinning as that happens. But since that velocity is essentially constant velocity, you can't tell. Your entire world is fine. When you're in a car and you're moving along at 60 miles an hour and you have a pen in your hand, like this one, and you have to toss the pen to someone in the back seat, is doing that any different than if the car was parked? Do you have to turn to the driver before you toss the pen and say, hey, how fast are we going before I throw this? I don't want to hurt anybody. No, because if you're moving at constant velocity, it doesn't matter. Your velocity, ready, this is the key word, relative to the person in the back seat is zero in both those cases. What we would say in physics is that you and the person in the back seat are in the same reference frame. The world to the two of you is the same in terms of velocity. Trees out there are moving, we're stationary. Really, I mean, I know intellectually we know that we're, quote, but really it doesn't make a difference. I mean, that's why they can do that thing on TV shows, where old TV shows, where the people would like be sitting on a bike and the screen behind them would show the scenery going by. I guess it would go like this. And you would, and it was supposed to, you're supposed to think it really is no difference. As far as you're concerned, from your reference frame, the trees are going by you at 60 miles an hour. And you know what? You could do all of physics and just assume that, and you would be fine. So, what you want to look at with this is from the perspective of what's happening. If I was standing on A, if I was standing on B, if I was standing on C, you have to assume that if I'm standing on C, I'm not actually moving. So pretend for a second that if you're at C and you're not moving, or no, even better, before we get to the asteroids, let's do this. So if you're in a car and you're moving along and you pass another car, so now that car is behind you. Now, if you pass that car, you have a bigger velocity than them. So their velocity might be 40 miles per hour, and you have a velocity of 60 miles per hour. You are going to, quote, move away from them, aren't you? In fact, if there was no other way to tell, if you couldn't see out your windows and you didn't know, you would even say this is going, you could even say that's going backwards, and you would still be right. Like, you can't tell. What you know is that in relation to you, this thing is moving away from you at 20 miles per hour. Now, the reality, as we look at it compared to like the Earth, is that you're both moving, but you're moving away 20 miles an hour faster. But either way, this distance between you is increasing at a rate of 20 miles an hour. Because relative to you, they're going 20 miles an hour or less. So if you assumed you were stationary, if you just woke up and you went to sleep and woke up and looked out the back, you'd see this car going away from you in your mind at 20 miles an hour. So that's kind of the mindset you want to have here. If I was standing on this, say, asteroid C, well, let's say if I was standing on the spaceship and looking out, ask yourself, as you go through each of the asteroids, is this asteroid coming, or is the gap between us getting smaller, or is the gap between us getting bigger? So if I'm moving at 600, and I look at E, for example, out ahead of me, am I closing in on E, or is E pulling away from me?
It's pulling away.
Now let's see, E is going at 400 meters per second. I'm going at 600.
Also, it's
right? So I'm going faster than it. I am closing in on it, right?
okay.
So E, I would say, if from my position, is coming towards me. I can't really, as coming towards me really means the gap between us is getting smaller.
Okay.
So, which other asteroid is, now that's E's in front of me, these other ones are behind. Which one of these is getting closer to me? So I'm going 600, right? Can I see this right? I'm going 600. Sorry if you couldn't see that before, but I could see it. Then, which one of these is getting closer to me as time goes on?
So
It'd be anything that's going faster than.
Oh, so B.
Right?
Oh, C
Right?
and B.
C and B are both getting closer to me because they are faster than I am. So as time goes on, they're approaching me. And in fact, C, for example, is this gap between us is closing at 200 meters per second, isn't it? The difference between us. So the relative velocity is when you subtract the two. This, B, is closing the gap on me at 100 meters per second. So let's have some little fun with this. Are C and B getting closer or farther apart?
I'm thinking.
So C is going faster and it's already ahead, so they're getting farther apart, aren't they? Good. What about D?
They're already going. Was B and C are already going faster?
All right, so compared to me though in the spaceship.
Oh,
So from the
spaceship.
perspective of the spaceship, it's important to know whose perspective you're looking at. Is D, is it closing the gap between me, or is it the gap between us widening? I'm going
Isn't it
600.
widening?
It's widening because this one's going 600, and I'm pulling away from this one, and it's widening at 200 meters per second. So list the asteroids that are moving towards the spaceship. Well, E is. Now I know it's the direction of its velocity is not towards it, but the gap is getting closer. So E is coming towards. C and B are coming towards me. List the asteroids that are moving away. Well, D. What about A? If you go to sleep and you wake up an hour later, A is moving at the same velocity as you. Where will A be? Well, if it's moving at the same velocity, it and you are in the same reference frame. So you don't even have to be in the same car to be in the same reference frame. If you and a car are driving down both at 60 miles an hour, you could, okay, ignoring wind resistance, you could toss the ball back and forth and not even worry about the fact that you're moving at 60 miles an hour. You could shake hands, right? And it wouldn't be a big deal. Because you're moving in the same reference frame. You have the same velocity. So A and the spaceship, both going 600, they're going to keep that distance between them. They are not moving relative to each other.
Oh, okay.
So A would show up as neither of these. It wouldn't show up in neither list because it is not moving away, not moving towards or away. And so we're really looking at it from the perspective of the spaceship. Which one of these am I like, dude, we're going to hit that asteroid, right? That would be your towards, the ones that I'm getting closer to.
Oh, okay.
The ones I'm like not worried about hitting me are the ones that I'm moving away from. So this is towards, this is away. So I'm not worried about D, but everybody else I'm going to hit them if I don't do something.